Okay, recording. So PowerCube design session with Tom, myself, Marcin, and Jean-Baptiste in Chile. We're working on a PowerCube version 15.6. So now we're shifting because there's so many different prototypes of the PowerCube right now, and you can look at the main PowerCube page on the wiki, which is simply opensourceecology.org/wiki PowerCube. You can see the genealogy, and you see we've been through a number of prototypes. The number is about 10 or 15 or so. It's versions on the PowerCube page, but you see we've got the version 15.6. Since we're kind of losing track of the numbers, we're doing a more sensible nomenclature for that. And 15.6 refers to 15 the year and 6 the month. So that is our frozen release for the workshop for July. We're going to build 6 of these PowerCubes. And with our team here, so myself, Tom is our PowerCube lead. Jean has been doing all our graphics. So on the PowerCube, look at the page on the wiki, PowerCube version 15.6. You can see the CAD is downloadable through Google Warehouse. So actually, if you click on the Google Warehouse, you can download the file, including STLs for 3D printing actually. But the page has a development template on it, basically where we keep track of all the different products that need to be developed and the state of completion, so that you can have the total done percentage off the development spreadsheet for generating burn down graphs. But basically right now we're working on the instructional, which is embedded into the page, so it's a Google Doc. And regarding the applications of the PowerCube, for us, we're doing some radical work on scaling. So scaling is a big thing for us. You can see that we're not inventing anything new. This is from Caterpillar, but basically people have been doing stacked power units on bulldozers, and this is a bulldozer case. Sidewise stacking of power cubes, so think about our power cubes stacked like this, but more than that, 2 to 4 to 8 to 6 to 8. Or you can train 2 vehicle pieces, like a train for a more powerful bulldozer. But that's the idea of how we intend to scale things. So for applications such as digging ponds and regenerating the earth, I just actually posted on Facebook the concept of a pond storage on our site, where if you look at this is just posted today. This is the June 13th at about 3 p.m. This posting shows that's factory farm there in the yellow boundary, but Lake 1 and Lake 2 are the proposed lakes or ponds that we're going to build. They're quarter-acre lakes or ponds. We're considering gravity storage, so between them, which on paper it looks like 24 kilowatt hours of storage, which is actually amazing. That could take us off grid if we wanted to. But the concept is, with a bulldozer, there's a lot of earth-moving work to build a pond, or to trench out a trench to run the water line between the two, if you want to do something like a gravity storage system. So that's something we're considering as a possibility for a future workshop. We'll evaluate that completely. But in the meantime, we're on the PowerCube modules. We broke down the PowerCube into a workflow. We're trying to design, if we have 6, we're currently designing for 6 work teams during the workshop. So if you look at, that's a basic schematic of our workshop. All the light green are the welding stations and workstations. So there's assembly cutting, there's CNC cutting table, hydraulics assembly, small parts welding, more assembly. That's what it's going to look like. So we're designing for 6 parallel teams to build 6 power cubes, a team of 4 people each. So we're planning on about 24 people at the workshop. Now, we've broken down a number of modules to be specific, or basically more by the function. So the 6 different workstations would be, there's cutting with CNC, so we're looking at having the CNC cutter. There's cutting by abrasive saw. There's welding with our welders. Ironworker station for punching and shearing. There's a hydraulic station for assembly of hydraulics. And then there's a tank welding station, or cutting and welding. The tanks are actually going to be the main challenge of the entire event, because that requires gas-tight ability to weld, which requires technique. And that's not an entry-level job. Two skilled people will have to do that during the workshop. There's also going to be a grinder station where we grind out a few parts that we need to. Drilling and mag drilling station for some of the holes that can be done using the hole puncher, such as when it's in an angle where you can't get the hole puncher bit in there, or when it's in a tank where you can't get, you have to have you can only do holes with the hole puncher on flats, not on tubes or anything like that. So there's going to be a welding station, safety, etc. And right now there's one jig that that Tom actually came up with for how do you do an effective, basically the pump mounting to the engine is the most precise part of the entire process. If you look at the power cube itself, basically, so you've got the engine unit. Let's see, this is looking at this off Google Warehouse. Let's see. Basically, the most complicated part of the assembly process, you can say, is mounting the pump on the engine. That requires a precise distance between the pump and the engine, precise distance and perfect parallel ordering. Perfect parallel and perfect distance for the pump from the engine, so that when we build it, we can work on the module. Basically, the engine module is going to be put together as one unit. The pump module is going to be put together as another unit. And basically, the Google Warehouse, what you see there, is outlined by all the different modules that exist. So you can examine that. There's the frame, hydraulic reservoir, the fuel tank, the engine, the hydraulics, the oil cooler. I'm trying to zoom into there. The hydraulic pump. There's the electrical section. It's a little hard to navigate here on demand. But yeah, pressure plumbing. There are controls, control parts, hoses, and everything else. So it's a bunch of different parts, but it's nicely lined out into clumps, where we're going to go through those bunches of items as modules so that the whole process is facilitated. Right now we're going through the specific directions for how to now continue with the build. So we're going to the Power Cube document. Let's see, so on the preparation of the jig, Tom, you've got the basic spacers for mounting the pump. So basically the detailed procedure is we're going to first cut the angles, we're going to then measure them, that they're pretty much, let's see, explain, Tom, what you're doing in slide number, let's see, preparations, slide 5, spacer
okay,
plate.
On the preparations, what we're going to do is cut 2 angle iron pieces, and these 2 angle iron pieces are to be used as spacers, as to space the pump mounting bracket, the 2 plates in the mounting bracket, so that they'll be as parallel as we can get the 2 surfaces.
Mm-hmm.
And so to do this, first of all, we take just a piece of angle iron and we cut off a piece about 4 1/8 inch long, and then clamp that onto a longer piece with the far ends parallel. You know, we can just use a square or a flat piece of metal, whatever, to clamp to position them so that the ends are flush with one another, and then clamp the 2 pieces together very securely using some C-clamps or other heavy-duty clamps.
Yeah.
And then put that back in the bandsaw and then cut the other end of it. But when you cut it, you cut both pieces of it, just maybe a 1/16 of an inch off of the end of the one that's already cut,
Mm-hmm.
and then cut all the way through the other piece. So
Mm-hmm.
the result is what we'll end up with is 2 pieces cut exactly the end with both pieces flush.
Okay.
So that should be 2 pieces the same size.
Mm-hmm. Mm-hmm.
And then once we get that, the bandsaw, it's going to have teeth on it, so it cuts it usually with a little bit of a rough surface. You run your fingernail over it, and you can feel the ridges in there where the teeth were cutting through the metal.
Yeah.
So for a more precise alignment of the plates, we'd like to get this polished a little bit more.
Mm-hmm.
So then in the second drawing, you can see down at the bottom. You want me to do a screen share so I can show this?
You could do that. Yeah, go ahead.
Um, Desktop, start screen share. Okay, so this is the first piece right here that I was indicating. So
Yep.
we clamped, this would have been one solid long piece, and then we cut 4 1/8 inches off of it and put it on top of this piece and clamped it securely. Made sure the ends of it were flush over here, and then took the bandsaw and cut again. So then we'd end up with two pieces the same length, and that should be about, let's say, 4 1/16 inches.
Mm-hmm.
And the actual length of it doesn't have to be really that precise. But what we do have to do is get the cuts of each end. We have to have it very perpendicular to the length of the angle iron.
Yeah.
And so that's what we're shooting at now. So the next thing we do is you can see on the second piece over here, I reverse oriented the two pieces so they make it kind of a T shape.
Yep.
And then reclamp it together. And this is really easy to clamp together because you can just lay both of those back to back on a piece of flat steel.
Yep.
And square up the edges and clamp it together.
Yep.
And then from there we take it and just slowly find a nice flat piece of concrete and just rotate it in a circular motion. And I found it best to hold it by the very lower edges of the angle iron itself so it doesn't rock from side to side, so that we keep that surface flush on the concrete and just slowly rotate it both clockwise and counterclockwise and back again, back and forth like that. And
but how do you check it's? I mean, how do you check? I mean, I'm having trouble with seeing how. Do you put like a square on the other side of it so you know it's perpendicular to the concrete block?
Well, in a way, it is a square in itself already.
I mean, it should be, but the point is that it's not, and we're trying to get it to that final. So you find that in practice it works pretty well, and you can measure that it's up. You mentioned that it's down to 1/1000th of an inch after you do this grinding step for what, like 5-10 minutes? Yeah, 10 minutes.
Yeah, about 10 minutes.
Wow.
And we also flip it one end to the other end. And then if you look on the next slide down, you see I started using 3 different calipers. And so we measure it at each of these 3 points. And like I was saying a while ago, the actual final length of it isn't that as important.
Right.
Is that each of these points, each of these measurements will be within 1/1000th of one another.
Yep.
Because what this means is that we'll have a very, very flat surface.
Yep.
And so then we have to have both of these two pieces. They need to be exactly the same length as one another as well.
Mm-hmm. Yeah. Okay. Well, that explains it. I mean, you've done it. You've succeeded at this, and we're going to see ourselves in the workshop how, with rubbing a piece of metal on a piece of concrete, we're going to get it down to 1/1000th of an inch accuracy in length. That's amazing.
Yeah.
Okay.
Yeah. It's an old technique they used to use in grinding telescope lenses.
Hmm.
And of course that kind of grinding had to be very precise.
Okay.
And so when we're finally done with these two pieces will be used to put in between the pump, the plate that the pump mounts on, and the other plate that suspends the pump off the top of the tanks.
Yeah.
And so those are the 2 plates that are important that they be parallel, because then we mount a third plate on top of that. It's the engine plate. And so the end result is that we want the shaft of the hydraulic pump to be exactly in alignment with the engine shaft.
Yep. And
so when we get to welding the spacers onto the pump mounting bracket, there are a few techniques about that, so we can weld it so we can make sure that the spacers stay aligned also.
What is that? What is the essence of that technique? Clamp tight, and of course, do
Um,
like gradual welding.
Actually, no, we don't really clamp it tight to begin with.
Mm-hmm.
What we do is you start with just one piece. Um, say the longer piece, and then we position the angle uh, iron pieces on that, and what we're going to do is we're going to have four pieces of angle iron. Now the spacers that we just created, like I said, they're going to be about 4 and 1/16 inches long. Well, the actual other pieces are going to get welded to the pump mounting bracket. They're going to be slightly shorter than this. And so we're going to have a little bit of
Oh, yeah, yeah,
space
yeah.
because
Okay,
we
these
want
are just the spacers. That's the point. These are just the spacers. We don't use these to... Wait, do we use these to weld or no? These are just our jigs.
no, these are just jigs, and we can reuse
Okay,
them from one bracket to the next to the next.
right. So we generate one of these jigs. We can use it multiple times. But the point is, when we cut the other ones don't have to be exactly same length because you fill it in with the welding, right?
Right, and they don't have to be terribly exact. They
Oh,
just have to be yeah. There you got the pump bracket there.
very nice. So you can essentially cut just with a cut-off saw or an abrasive metal saw, and because you have the precise spacers, these can now be welded just like they are.
Right,
Very nice.
and so the way we would do it is first of all you see how the angle iron pieces are on the left and right on the drawing right there,
Yeah.
and those two pieces when we go to weld that, I would go on the inside of the hole here and weld the very corner, weld that down to the plate so that when the weld bead when it cools, it'll draw the it tends to shrink just a little bit, and so when it cools, it will secure the entire angle iron piece to the plate
Yeah.
without tipping it to one side or the other. If we welded on the outside anywhere, it would tip it in one direction or another.
Oh, because it oh very nice because it has the feet of it that are next to the metal already, so it can't bind down.
Right.
Very
Right.
nice. Okay, that's very important. Okay.
So that basically that's a tack weld on the inside, and
Aha.
then we get all those tack welded, and then go back and put a nice bead all the way around.
Very nice.
And just to make it super strong, I put a weld on the inside and on the outside.
Mm-hmm. Yep. Very nice. Very nice. Mm.
Um, yeah, and then uh, we would weld it both. The way I would start out is by welding those first of all to that 6x6 plate that has the hole in it, and then invert that with the spacers, and then weld it to the longer plate. And then because we have a little bit of the shrinkage of some of the weld pieces, uh, it usually takes a crowbar or something to get the spacers out of there, the
Ah.
jig.
Okay. So can you draw when you do the detail there? Draw in the clamps and the and a pry bar, things like
Okay,
that. Hmm.
I can do that.
Where are the files for these explainer pictures here? Is that within the original file or that's a separate file you're using?
Um, the file for what now?
When you have your jig pictures that you screen copied, is that the same file as the source file for the CAD?
Oh no, I just drew those up just for this presentation.
Okay.
I did it just a little while ago.
Okay. Can you upload that source as well? That would be useful too. Wherever you
Okay,
can.
you want it to warehouse or to
Yeah,
the
warehouse would be. Warehouse is good. Just so if we have to modify it or make changes on these, then we can just download them again or modify them, so
okay.
we don't
You
rely
want
on
to
you to do
use
that.
these elements for other.
Yeah, yeah. We want to use the. Could definitely use the clamps, just little library
Right.
parts. That I mean, those are good clamps. We'll take them.
Yeah,
Okay.
these like the seat clamps and that kind of thing. I just found those on the warehouse.
Yeah, that's
They
great.
were out.
Yeah. Okay. Excellent. Looks like it's all coming together. Good explanations there. So let's work on maybe let's continue on detailing the workstations like we started yesterday though. Yeah. So I think we're in good shape on. That's a good tutorial on the jigs, which pretty much if you can understand how to weld the pump on straight, that's the main thing. The only other non-entry level task is then welding the tanks. But other than
Yeah,
that,
we
it's all just bolting
also
things
on the
together.
next slide down, I have the jig also for the shaft
Yep.
coupling plug.
Yep. Yep.
And so that one, I just started on that. I was typing it up while we were talking earlier.
Mm-hmm. Mm-hmm.
And this one is for aligning the two shaft coupling.
Yep.
Now this time the engine shaft, the coupling for it is a 4 inch long piece, and I think that one we can still cut that in half, and that should be plenty strong enough on the engine side. But now with the 5/8 inch shaft, um, the shaft on the pump itself is 1 1/4 inches long, and then the coupling that we get for that, it's also 1 1/4 inches long, so we can just use it one piece.
Okay.
And
That's good.
so we need to make a plug for this to match that to align the two halves for welding, because this is a similar kind of an issue. In order to maintain the shaft alignment, we got to get these welded exactly right.
Exactly. Yep. Mm-hmm.
So in doing that, the plug, uh, I'm going to have the plug made to where it will maintain alignment using the inner surfaces of the shaft couplings. And then the plug is going to be a little bit longer, a little bit shorter than both of the couplings together, so that when we assemble that, we put the plug inside the one half and then put the other half together, and then we clamp it all together with a C clamp. That the C clamp will clamp against the coupling halves and not against the plug.
Right. Mm-hmm.
And then we just basically uh, weld it. But now just for an extra little tidbit, um, in order to aid with the alignment, the two surfaces of the coupling halves that we put together, uh, I have been using the surfaces that were machined when the shaft coupling was made, so it was the outer surfaces, and not the ones that I cut with a bandsaw, because the bandsaw tends to have just a slight irregularity, and so that using those machine surfaces from the manufacturer will help align the
Yeah.
couplings better.
Right. Right. Good point. Excellent. Should we get into the detailing further the workstations then?
Okay, let's go. What slide is that? Slide 9?
Yep. So starting slide 10. Okay, let's do that. So that there's a lot of detail here. I think I'm going to cut off the video right now. That's a good intro to where we are on this, good overview of where we are, and actually we recommend that the people who are going to participate in the workshop just go through this if they want to get a deeper understanding of what's going on in the actual build. Okay, with that said, I'll cut this off here and